For this example, we got to check whether x equal to 0 is a singular point or ordinary point. So in that case, we got to rearrange our differential equation in order to satisfy px and qx. So when you take a look at this, you know that we have two values of x, which is make qx and px not an analytical function, which are what? Two values of x, which is make px and qx is not an analytical function. What are those numbers? 2 and minus 2. So in that case, we are considered at x0 is equal to 1. So 1 is an ordinary point. Therefore, in order to find the solution of this differential equation, we got to assume y is equal to summation of this term. And then we put x0 equal to not 0, 1. So now our power term, it doesn't look easy as it used to be. So in order to make it easy for us, we are going to replace x minus 1 equal to t. So instead of as a function of x, we are going to make it as a function of t. So any x inside the equation, we got to replace it with this definition. Okay, so now our y is equal to summation n equal to 0 until infinity a n t to the power n. And our differential equation, we have this. But since our y is in the function of t, so we've got to change in every x inside our differential equation into the term of t. Okay, and by using this definition, from our definition we would get x equal to t plus 1, right? From this, because we assume that x minus 1 equal to t in order to get t to the power n there. So by this one, we would get x equal to t plus 1. And then we plug x equal to t plus 1 into our differential equation. In that case, we can change our x into the term of t. So what do we get there? 4 minus t squared minus 2t minus 1. Which is equal to 3 minus 2t minus t squared And then we are going to plug our y into our differential equation. We have y equal to summation a n t to the power n equal to 0 to infinity. We got to find the first derivative of y, which is equal to a n times n t to the power n minus 1. And the second derivative of y, because in our differential equation we have the second derivative of y. And then we plug our y and its derivative into our differential equation that we already replaced x with t. So I put star there, put into the star equation. So we would get ten plus 12. And then what we are going to do next is just that distribute each term, and then after we distribute each term, then we would try to put the same power of t together, and then do the shift of index in order to make the power of the t the same. Right now it's just kind of routine, right? Just follow the steps like this. So we would get that is the first term, right, for 3. And the second term we have minus 2t, and t there we are going to combine with t to the power n minus 2. So the second term we would get t to the power n minus 1. Okay. Right, because we combine this t and that t together, so we would get n minus 2 plus 1, which is equal to n minus 1. And the third term, minus t squared, you have t squared there, you have t to the power n minus 2 here. Combine them together, you would get t to the power n. It's such a long line, so the rest would go to the second line there. Minus, again, 2, you distribute 2 to the t, you would get 2t times summation of a n n t to the power n minus 1. We have t here, combine this t with t to the power n minus 1. You would get t to the power n. But the second term here, because you don't have any t there, so you just distribute your 2 in there, you would get minus 2 times summation. And you turn t is equal to t to the power n minus 1. And then our last term, now you have how many terms there? 1, 2, 3, 4, 5, 6 terms. In 6 terms, we have term 3, 4, and 5, which has the same power of t. And term 2 and 5 have the same power of t. So you just put them together. Then you would have only 3 terms left. two terms, they look the same. We put them together, we get we take 2 out there. I would put like this: n minus 1 plus a n times n, t to the power n minus 1. T n. And the last term, which is t to the power n, we combine them together, we would get, we take minus out, inside we have an times n minus 1 here, and this one we got plus 2 n, and this term we have, okay, got 3 terms there. Every term has an. Summation. This one we have an and n the same. We can take an and n out. So inside we have n minus 1 plus 1. And this term we have an the same. So we take an out. Then n minus 1, 2n minus 12. And then we combine them again, we would get this one minus 1 plus 1, 0, right? So you would get n squared an, t to the power n minus 1, right? Our second term, because plus 1 and minus 1 is cancel out, you have only n. n times n is equal to n squared. And the third term, n squared minus n plus 2n equal to n. So you would get n squared plus n minus 12 an t to the power n equal to 0. And now we are going to do the chip of index. We are going to make every term to be t to the power n minus 2. Right? We got to make it as n minus 2. Then the second term and the third term, you got to replace n with term 2 and 3, right? Term 2 and 3. To be n minus 2. So that means the second term we replace n with what? The second term, in order to make it to become n minus 2, we got to replace n for the second term with n minus 1. And for the third term, we replace n with what? N minus 2.